Hello everyone. I'm gonna do in quiz 11 something that I find important and because we will use it many times and so I want you to know how to do it, but it's really not hard. So I'm gonna explain this on two examples. I don't want to make them too difficult. The actual examples, the actual quiz will be the same type of question. So it's just the only thing is it's very easy to make a little mistake there. So double check, triple check your answer before you submit it. Give yourself the time to double check everything. But very important, and I will stress it several times, is whenever you have to calculate the mod function, so modulo, well, we'll see what I mean. So whenever you the mod, right? You have the mod functions. You have to show me how to do that, and I want you to show that you can do it two ways, but I prefer you do it using the division algorithm, right? Because the division algorithm actually calculates both the diff and the mod, so you have everything there. But we only need the mod, as you will see. So what is the type of question that you can expect? I'll start with a bit easier, perhaps one, is this one. Oh no, I want to use regular pen. 13 to the power 85 mod 100, and the easy part is because I'm doing modulo 100. You'll see immediately what I mean by that, but still there are some calculations to be done. So okay, first of all, you cannot just put 13 to the power 85 in the calculator. We have argued about this number is way too big and the calculator can no longer do mod 800. Okay, so how does it work? Well, the first step is we take the exponent. So don't take anything else. It's the exponent is 85, and that we have to write in binary. Now we don't really need the binary description. What we need is how does it decompose in some powers of 2, which is basically the binary. So what is this stupid thing? Sorry. Okay. So what you do is you take the powers of, you write the powers of 2 here. I like to do it this way. I'm not saying you have to do it that way, but that's way I can follow it a bit. Okay, 85, and then the next one will be 128, right? But that will be too big. So we're looking for the first power. So we write 85. What's the biggest power that I can put in there? That is 64. What is he doing? 64. Okay, so we have 64. And then what is remains is, so this is not long division, right? So here I'm just finding the biggest power that that fits in. This is finding the binary description. It's different than the one that is explained in the textbook, or that I also explained in the lecture, namely, normally to find an expansion with base b, we do the mod calc, we do the division algorithm each time. And that works too, but in binary, it's sometimes simpler if the numbers are not too big to do this procedure. So I repeat, what you look for the biggest power of 2 that fits into 85, and then what is remains. Okay, what remains is 21, right? Yes, okay, 21. So now we look for the next biggest. What now? We repeat now with 21. So 21, 32, that's too big. 16, that will go in there. So let me mark my 16. So I'm going to use 16 now. So I split 21 into 16, and what remains is 5. And I keep doing this now with this 5. So 8 doesn't go in there, but 4 goes in there. So I take 4. So that is 64 plus 16 plus 4. And what remains is 1, and that's already a power of 2. So I don't have to do anything anymore. So these are the numbers that I want. So let me circle my 1 as well. Now, it is also just to, it's not, as I said, it's not necessary, but just let me clarify, why is this binary? Well, it tells me that I have a 1 for these 3, and a 0 for these 4, and 0 for the other ones. So this binary, in binaries would be 1, 0, 1, 0, 1, 0, 1. Okay? But what we really need is this. You will see. Well, you should have seen it in the lecture video, but I'll do it again. So now, we start with calculating, I'll make a table like this. Perhaps it's easier if I give myself, no, that's not, where is my paper? paper here. Okay, let me give myself lined paper. This one, okay. So I'm going to here write the powers of 13. 13 to the power first 1, 13 squared, but not all powers, only the powers, but I take each time the square, so that means I double the exponent each time. And how many times, how far do I go? Well, exactly to that, until I reach the last of these guys, the biggest one. So these I will use, because remember why. Let me very quickly try to remind you why this is, that we do this, because this quantity here, 13 to the 85, is 13 to the 64 plus 16 plus 4 plus 1, and that is by rules of exponents, 30 to the power 64 times 13 to the power 16 times 13 to the power 4 times 13. Right? This, if you multiply various powers, you add the exponents and you get this, you get that. So we're going to exploit that, because we're going to calculate these numbers. So we're going to, and what we will need, so perhaps already mark, the 64, 16, 4, and 1. So this one that I get here, this one, and that one. Now, why do I have to calculate the other ones? Because I have to keep squaring. It's a process, you build it up step by step. You cannot skip the step here. In this particular case, you could have actually take the fourth power, but let's stick to the actual process that works all the time. Okay, so here we go. And then, okay, that's one thing, but of course these numbers will get big. That's the whole point. I mean, 13 to the power 85 is a huge number. That's a number with more than 85 digits, because 10 to the power 85 is 85 digits. So what we're going to do is each time calculate this thing actually mod, or this actually should have been mod, sorry, I sometimes forget that I should. So we always, whatever we do, we calculate our result mod 100. Now that in working modular 100 is extremely simple, so I will do a second example where there's more work, and that's why I want to keep the two problems a little bit separate, that you get the hang of the method, and then you can, on the second problem, you'll see a bit more what more is involved. Okay, so here we go. So 13, well, so this is 13. So this is always, well, remember there are two different ways, mod 100, the bold phase and the light phase one. And it's easier to write the light phase, and they can write this is equal to, is equal to, is equal to, is equal to. So 13 is of course equal to 13, and that is already a residue, that's already, remember, these are elements that lie in Z100, and that is 0, 1, 2, all the way up to 99. Right, that's the remainder, so 13 is there. Now 13 square, of course, is not. So what is 13 square? So this is 13 square. Let me get my calculator next to me. It's easier if I put it this way. Okay. 13 square, that is 169. Okay. But, as I said, we're gonna not take 169 and square it, because that's exactly just work. That would be just working out this thing, right? The whole point is that we're gonna, what is called reduces modulo 100. So we're gonna find the remainder with division by 100. Now, this is how you do this, right? You use the division algorithm. It's 1 times 100 plus 69, and so this 69 is the residue. Is the remainder. Sorry, residue is a word that mathematicians use, but that's not for you guys. So, and then the next step is that 69 I'm now going to square, because squaring this, since these two are equal, well, sorry, I should have said equal here with the triple line, modulo 100. I'm not always going to write the 100, it gets tedious, but since these two numbers are the same modulo 100, the squares are the same, so I can square here. Sorry, I didn't write the square yet. So I'm going to do 69 square. Okay, what is 69 square? The calculator is 4,761. Now, I want to find what is this modulo 100. Okay. Sorry, I'm struggling here a little bit with my paper that is flying all over the place. Okay. Well, this is 47 times 100 plus 61. It's very easy to do the Euclidean, the division algorithm using 100, right? It's basically split off. You see what, we'll do it a couple times and then you can figure it out yourself, right? So this is 61, not 100. I'll write it one more time here. So, and this 61 is the one, sorry, I keep circling this one, I should circle the last one. It's this 61 that I'm going to use in the next step. I'm going to square that guy, not the previous number, but this one now, 61 squared. Okay, 61 squared is 3,721. So this part is just calculator, right? But I can immediately see now, can you see immediately what is the remainder? 21, right? It's the last two digits. Think about it. What does it mean? Well, how would you split this? This is 37 times 100, 3700, plus 21. So 21 is the remainder. So with the modulus 100 is extremely easy to find the remainder. And so I'm going to therefore now speed up my calculation a little bit. So I take this 21, I square that one. 21 squared, that is 441. So this is the same as 41, the last two digits. A square again. So notice that I'm not using these numbers, right? The only thing I'm using is that from there to there it is squaring. So each step is a squaring. Okay, and so the last step is also squaring. Therefore, this is what I do. This is 41 square. Okay, that's how you go. This left thing is just keeping track of where I am. And I need it later anyway, but so I'm not using those numbers. It's kind of labels if you want. So 41 squared, what is that? Well, 41 squared is 1681. 1681, so this is 81, the last two digits. And then finally 81 square. 81 square is 6561. So this is 81 square, which is 6561. So this is 61. Okay, that's step 2. But now comes the step where we put everything together. So step 3. What we need to do now? Well, we go back to our step 1. And so I remember we had these yellow ones. We said 64, 16, 4, and 1. These are the powers I want. So this is the first power, the 4th power, 16th power, and the 64th power. So these are now the numbers that I'm going to multiply. I remind you here, this is where this comes from, right? Okay, so the answer is going to be, well, modulo 100 is going to be that 13. This 13, and then 61, and then 41, and then 61. Okay, 13 times 41 times, then 61 times 41 times 61. The order in which I write is not important, but I just don't want to lose something. Now, we still have to work this out. What is this modulo 100? So all this is modulo 100, right? So I not keep writing this. Now, how do we do that? We could put this whole thing in the calculator, but these numbers are going to get bigger. The calculator can deal with it, but let's do this how we were supposed to do. That is, we do groups of 2. So we do these 2 together, and we will do these 2 together. What is 13 times 61? 13 times 61, that is 700. So this is 793. So what is that modulo 100? The last 2 digits. Okay, what is 41 times 61? That is 2,500. This is 2,501. So this is just 1. Right, the last 2 digits. That's 1. And finally, so what is the whole thing? This is 93 times 1. So 93 times 1, that is just 93. And that's your answer. All right? So that's how we do this. Let me do another example where it's the modulus is a little bit more involved. So it's 144 mod... 144 to the power 138 mod 139. Okay, so this is a review, but this is, don't just stare at the screen, stop the movie, try to figure it out yourself, and then see where you're wrong, right? That's how you learn things. Okay, so step 1, we have to write 138 as a sum of powers of 2 here. Okay, so let me just copy my little thing here, then I don't have to. Oh no, but if I do this, there are circles. No, let me not do it. I'm gonna not do it. Okay, I'll write them again. So it's 1, 2, 4, 8, 16, 32, 64, 128, and that's big enough, right? The next one will be too big. So this is 128. That's the biggest one that fits in there, and what is left is 10. And now look at 10. What can I fit in 10? Well, not 64, not 32, not 16, 8. So 128 plus 8, and then plus 2. And 2 is already a power of 2, so I'm done. And this always works, because we are looking for, what we're finding is the binary. So these are the ones. So in binary, this would be, remember, a 1 if the number is there and a 0 if the number is not there, so that would be a 1, then 3 zeros, then a 1, a 0, a 1 and a 0. That's the binary of 138. But we don't need that, we need just these 3 powers. So step 2, now we do again, we calculate this, keep squaring the number that we start with our base number, 144, that's now the base. So we do 144 to the power 1, okay? And then we do 144 squared, and then 144 squared. We square this again, that would be to the power 4. Squaring means doubling the exponent. We double, so we keep doubling the exponent. 32, 144, 64. Can I stop? No, I have to go until this, the biggest power here, 128. Okay, so 144 to the power 128. All right. And so this I will again calculate here mod 139. Okay, so this instead of using the function what I did, right, I'm going to write here always mod 139. So this is always going to be modular 139. Okay, let's start. Now 144 itself is already too big. It's not. See this should be the remainder should be an element in Z 139. It should be a number between 0 and 138. 144 is not, but it's of course easy to see. It's 139 plus 5, right? So this is 5. Okay, so we use this 5 and we square it because repeat, the next, if you are in somewhere in a line, the next line is obtained by squaring, and you square to both sides. Okay, square both sides, that becomes 25. But that's already a remainder, so I don't need to do anything. So I square 25 again. Okay, so this is 25, so square this again. This is 25 squared is 625. Now that is bigger than 139, so I have to calculate what it is. So how do you do this? Well, you take 625 divided by 139. That is 4.4, so this means that is the diff is 4. So 4 times we can put 139 in there. And what is remaining? So we have to calculate this number first. 4 times 139, that is 556. And now we look at what is missing. So what I have to add here to get to 625. Okay, I mean, if you can see my clock, it's a bit late, so I'm going to do this. I'm going to take my calculator for that. So 69. So this means that 69 is the remainder mod row. So this is where, I mean, this is the division algorithm, right? You divide by 139 as a quotient. This what we calculate here is what we would call, this number is 625 div 139, and then this number is, the remainder is 625 mod 139. Okay, so that's what I was trying to say is that the division algorithm gives you both these functions. These calculates both these numbers for you, but we only need the second one. And I want you to do it that way so that I see that you understand how this works. Okay, 69. So, okay, I don't need this intermediate calculate. I shouldn't have erased that. Okay, so I now take, again, square both sides, so I'm going to square 69. So 69 squared is 4356. 4356. So how many times does 109 goes in there? So divide by 139. That is 13 point something, so 31 point something, so 31 times. So we have 31 times 139, that is 4,000. So this is 4,309. So what is missing looks to me as 47, right? Let me cheat a little bit because I just want to, no, I did something wrong. What did I do wrong? Sorry, let me do this. I want to make sure that I get the things right here. I don't want to make mistakes because it's going to take me forever to find the mistake. So, what was it? 69 squared. Let me double check. 47. Oh, see, I did that. I typed in. I have to type this. This is what's wrong. So, 69 squared. What is this? 69 squared is 4761. 4761. Now divide this by 139, that is 34 point something, so 34 times 139, how much is that? 34 times 139, that is 4,726, 4,726, so what is missing is 35, right? That's, if I add 35, then I get 4,761. Okay, this tells me that the remainder is 35. Great. I can do this again. So now I'm going to square this guy, 35 squared. So 35 squared, that's 1225. And now I have to divide this by 139. The result is 8.8, so 8.8, but I'm going to take the floor of that. Okay, so that becomes 8. Okay, and times 139, how much is that? 8 times 139 is 1112. So this is 1112. And so what is missing is 113. Is that okay? Yeah, it's smaller. As long as it's smaller than 133, it's fine. Okay, so this means that this is 113, the remainder mod 139. Okay, so again, I get rid of this guy. And I square 113. Okay, 113 squared is 12769. 12769, divide that by 139. It's 91 point something, so 91 times it goes in there, times 139. So 91 times 139 is 12649. 12649. So what am I missing? It seems I'm missing 120. Okay, so that is now my remainder. Okay, now this row is equals here, right? Okay, so now I square 120. 120 squared is 14,400. So divide that by 139. It's 103. Point something, but that's the thing. You always take the floor of this times 139. That's now this part is the Euclidean, the division algorithm. I always say Euclidean algorithm because that's what people normally call it, but the textbook for some reason calls it just the division algorithm. Times 139. It's 14,317. So I am missing 83. I'm missing 83, right? Okay, that's. I hope you understand, right? So this number is that product, and what I do is subtract this from that, and that is the 83, but I write it here as it is being written in the division algorithm. This is the Q, this is the R. Okay, so this can go. So this is 83. So if you write equal instead of this triple line, that's okay. I do this all the time, but I try to not forget it. So okay, 83 squared, that's the last of our things, luckily. That's 6,809. So divide that by 139, that is 49 and a bit. So 49 times 139. 139 times 49, that is 6,811, 6,811. So what I'm missing seems to be 78. Okay, and so this is that. That concludes the calculation of these various squaring. I repeat, I didn't say this, but I should mention this. The algorithm as described in the textbook does things a little bit differently in that it already does combine step 2 and step 3. Now, I find that very dangerous because you make much quicker mistakes when you do that. And I like to keep things separate. Okay, so that's how I always explain it. If you do it otherwise, okay, just be careful. And so step 3 now, this is where I put my everything together. What I'm looking for, well, I'm looking here for these powers. So the second power, the 8th power, and the 128th power. These are the 3 numbers that I now have to multiply. So the answer is 25 times 35, no, not, yeah, 25, yeah, 25 times 35 times 78. Okay, and this I have to calculate again, modulo 139. And you could multiply it all together, but let's really follow the algorithm. So we do 25 times 35, that's 875. So if we divide that by 139, it goes in there 6 times. So this is 6 times 139 plus something. Now, what is this? 139 times 6, oops. What was it? 139 times 6 is 834. So what I'm missing is 834. So in other words, if I subtract, I get a 41. Okay? So let's get rid of this particular thing. What does this now mean? This means that this is modulo 139 the same as 41. These two numbers, these two. Okay. Now, if there would be, in the previous case we had 2 pairs, but here's only 1 pair, so this is the same as 41 times 78. So that's my last calculator. 41 times 78 is 3,198. If I divide this by 139, that is 23 point something, almost 0, but it is not. 23 times 139. 23 times 139 is 3,197. So what am I missing? Oh, I only miss 1. So this is 1. Who would have thought that of all the numbers I come out is very easy number 1. Now again, there is actually a reason for that, and that's you have seen it in today's lecture, I'm sorry, I'm making this before I put in the lecture, so I am not 100% sure how far I got in today's lecture, but either we saw today's lecture, we'll see next lecture. This is the Fermat's little theorem, okay? And we will use it to revisit this problem, to make it much simpler. Although in this particular case, yes, in this particular case, of course, it is simpler because I knew from the beginning this answer is going to be 1. Okay, but I'm not spoiling it why, and also on the test I'm not going to ask you something like that you could use that. No. Okay, so that's for the quiz. It's easy enough, it's just following the strategy, but keeping your head cool, and check, double check. All right, and I remind you that in calculations, on a quiz, you're not supposed to use any tools other than your regular calculator and your beautiful brain, and of course all the notes and whatnot, and the videos you can look at. But in homeworks and so, you can use Wolfram Alpha to double check your answer. So, but I would like you to refrain using these things. That is what you promised on your word of honor, that you only will use during the quizzes, for the quizzes, the purpose of quizzes, to use calculator, textbook, notes, and videos only. Okay? And of course, no, don't ask your cousin, don't ask your mom, don't go make a call to the president, which at this time of recording, I still don't know who is our next president. You guys will know, and okay, let's not talk about that now. Okay, see you in the next lecture.